Welcome back. So we just finished creating a very simple node class and the doubly linked list beginning class with the initiation and the print method. And we looked at how insertion is going to work with a simple example. Now we're going to actually employ it and start to do methods. So this lecture is going to be just for the insertion. It's going to have two methods, one to insert at the beginning and one to insert at the end. You can insert at the middle if you want to. Just to be quick, we're not going to do it in this example. If you want to do it later on your own time, all you need to do is just traverse, look for the location that you want to insert after, and just insert it normally, just like what we are going to do right now. So I'm going to start with creating the method to insert at the beginning. Let's call it insert at start. Of course, the insertion method is going to need the data that we're going to create the node with. Now, in here we need to say this. We have two types of insertion. You can either receive a number or a value for the data, and inside of the insertion method, create the node itself and then insert it, or you can receive an entire node that was created and insert it in your insertion method. This example is going to look at receiving a number and creating a node inside the method. And you can work on inserting an entire node on your own free time. So since I need to insert something in here, I need the data for it, create the node with this data. And what I want to start doing in here is, first of all, of course, create node. So a new node equals node. It's the name of this class up here. And I'm going to call it with this data. When I call it with this data, it's going to go and, of course, when we create an object from a class, it's going to call the constructor for it. Since I sent data, it's going to take it, give the data to self.data, and have next and previous as none. So after this, what's going to happen is fairly simple. All I need to do is ask a simple question. Am I inserting into an empty list? Is this an empty list and you want me to insert in it? And I can ask that by just saying if self.head is equal to none. That means the list that I'm working with is actually an empty list, it contains nothing. And in that case, I don't need to do any type of pointers, just self.head equals the new node that I created. Why? Because if I have a single node, if this was an empty list and I want to add this single node to it, then there is no previous and there is no next, which means both equal none. And as you can see in here, we already gave it none. Else, for this condition, so I'm asking, is it an empty list so that I can just add my node and finish? Well, if it is not, it's going to come to the else. And there, I jump to the else, that means the linked list is filled with some nodes, and this is insert at the start, so I want to add at the beginning. What I want to do in here is self head previous is going to equal what? If you remember it from the last lecture, it's going to equal new node. So right now head is pointing towards the first node, and we just said head, your previous is none. That is because the first node will always have the previous pointer as none. It's the first, nothing is before it. So how about you change that self.head.previous equals new node. So we want you to point towards new node. But right now head is still, the first node is still actually the one that head is looking at. What we want to do next is say, okay, so my node, the new one, right now the first node is pointing to it, but it is not pointing to the first node. So the one that I created is not pointing towards anything. Let's solve that, and we can say new node dot next equals what? About quickly. That's good. Self.head. What we just did is create. Let's say that we create It's a very simple one in here. What I did in reality was head head.previous, which is none right now, pointing towards nothing, equals new node, point towards it, and then say new node.next equals head. So they are pointing toward each other, but right now head is still pointing to the older first node, and we want to change that. It's very simple. We're going to do self.head equals node. That is going to make my new node the first node in that linked list. Now, we just finished inserting at the beginning. I'm going to insert at the end, and then I'm going to do a simple main program that can verify and test whether this is working or not. So stay with me. Now we're going to jump to the method that inserts at the end. It's called insert at end. Same thing, it's going to take self and data. Now, when you insert at the end, what you want to do in here is one of two things. If you are using tail, head and tail, just jump to tail. Jump to tail. Tail is always going to point to the last node in a linked list and do your insertion there. But right now in this program, I'm not using tail, and that is why I need to do a traverse. I need to start at the beginning and jump all the way to the end. Before we do that, again, create your new node equals node with data. Same thing as above. And since this has traverse, I need another pointer to work with. So current is going to equal self.head. Then I'm going to do a while loop. This is a normal traverse. We have done this so many times before. While current dot next is not equal to none. Look at this. While current dot next, I'm not saying that current itself is none, but current dot next, because with this type of condition, it is going to stop when current dot next equals none. That means it's going to stop on the last node, because the last node always have the next value of none. Okay, so and here it's going to be a normal traverse. So current equals current dot next. That's just I'm jumping from the beginning all the way to the end. I started at the head, and I'm going to keep on equal my next, jump all the way until my next equals none, which means I'm the last node in this doubly linked list. When this while loop ends, we are going to be at the last current is going to be pointing towards the last node in a linked list, and then all I need to do is say current dot next equals my new node. I wanted to point towards it, and new node previous equals what? About it quickly. Right. Very good. So the main idea in here is fairly simple. If this one, if I wanted to add this at the end, then I'm going to do a traverse, and current is going to start at the beginning at head, jump, while next current dot next is not equal to none. When you reach this point, and if we just do this, so at this point current dot next is none. There is nothing after it, and I want to add this. All I need to do is say current dot next equals a new node, point towards it, and a new node dot previous equals current. You also point towards the one before you, and that's it. So it's that simple. And with this, we have finished actually inserting both at the start and the end of a doubly linked list. What we want to do in here is do a very simple main program. So L equals, what did we call doubly linked list? Okay, so doubly linked list, quickly nothing. Then we're going to do L dot insert at start. Now let's do 3 inserts at start. If I insert 3, 2, 1, it should be 1, 2, 3 because I insert 3 at the beginning. So 3, I'm going to copy and paste in here, and 2, and and 1. So it's going to insert 3, then add 2 before it because it's at the start, and then add 1 before it. And I'm going to print in here, so L DLL. Let's check it quickly. Yes. So 1, 2, 3. Inserting at the start is working. When you do those types of testing, don't delete your last type of test. So I want 1, 2, 3 to start so that I can check if inserting at the end is also working. Because in here I'm going to do L dot insert at end. Let's say I add 4, copy and paste 5. So this should make 3, number 3, insert at beginning 2, insert at beginning 1, and then insert at end of 4 and 5. So the result should be 1, 2, 3, 4, 5. Let's check that quickly, and it is. So this ends our insertion lecture for the doubly linked list. As you saw, it's actually very simple, and it is really similar to the single linked list. We're going to look next at how to delete from a singly linked list, a doubly linked list, and we're going to look at how to delete from the beginning, the middle, and the end of a doubly linked list. Thank you so much for listening, and I'm going to see you on the next lecture.